So that brings us to the last speaker in our session, who is Tom Wise. Tom Wise is a principal geologist at the Geological Survey of South Australia. Over the last decade, Tom has worked on regional geoscience and mineral potential projects across SA and has recently led the GSSA's National Drilling Initiative project in the Delamerian, which is what he'll be telling us about today.
Thank you very much. Great that you've all stuck it out to the end of the day, and hope to finish on a fun note. So, National Drilling Initiative. It's one of the 3 programs within MinEx CRC, and it aims to really tackle a problem of frontier exploration country, where we're seeing cover thicknesses that have been, I guess, seen as a bit too risky in some places. So we as a geological survey thought, let's jump in with the National Drilling Initiative, let's commit some money to that, let's go tackle some of these questions and see if we can open up some new frontiers. So how do we do that as a geological survey? Well, that's through pre-competitive geoscience. I'm not going to talk at all about machine learning or data or things like that. Really what you want in a greenfield scenario, you want an idea. You want something to trigger your investment into that greenfields terrain, and that's an insight built on value-added data, built on acquired data. So what we did throughout the Delamerian NDI, which is in the east of South Australia under the Murray Basin, we went through a project cycle that looks something like this. So we started off in 2020. We earmarked a section 15 over the ground where we wanted to work. We did some legacy data capture that you've seen earlier, some examples from Liliana. And then that really led us into a gap analysis, which led us into drilling, which led us into releasing drilling data as quickly and as efficiently as possible, which led us into releasing some of the ground. And we're currently in the phase of writing up that work, undertaking some further research and analysis, and coming together with some of these ideas to try and attract exploration into some of these greenfields terrains. So a good way to look at it is we attacked the area, we interpreted some geology, we predicted where some interesting regions might be, and then we went out and tested those hypotheses. We did that with the MinEx CRC coil tubing rig in parallel with a conventional drilling technology, mud rotary and diamond. In our 2 drilling areas, we first sort of brought the coil tube rig in as an advanced field trial, really, in our Alawoona area, and then when we went further north, we took it really into the greenfields exploration scenario for the first time. That returned us some fantastic rock samples, some wonderful chips and dirt through the Murray Basin and into basement. And then we took a cord sample, from the end of hole when we were in fresh basement. And using, techniques to bring out as much as possible out of the information from downhole, we're able to generate some plots such as Mario did in the bottom of the figure there, which shows exactly how well some of these chips are marrying up in their PXRF geochemistry with downhole gamma and MegSus. So I'm not going to go through and spell out everything we did with the project. You'd be getting pretty thirsty by then. So what I can say is we're in the process of writing a lot of this up right at the moment. A report book is getting pretty close to a publication stage. We've done a huge amount of analysis on both our new NDI samples, but legacy samples from pre-existing drilling. We've done some new geochronology, some new geochemistry, some petrology, scanned everything through the high logger. We've tried some novel techniques to investigate where, traditional analyses might not be so effective, and really characterised everything that we've drilled to a pretty high standard. So that really takes us towards that. That's the data that we collected. We've value-added that by working through some of the geochronological studies that Liz Jagodzinski has been up to, as well as Claire Wade looking at the geochemistry, and that really ties us into a I guess, a much deeper understanding of what the regional geology is. So we've figured out that magmatism underneath the Murray Basin really fits in at the start and the end of the Kanmantoo group depositional cycle. We can show that magmatic compositions evolve from, I guess, a continental rift type scenario to much more of a back arc type regime. And that's backed up with geochronology, geochemistry on all the magmatic rocks. We've also looked at the volcanosedimentary successions in the Kanmantoo group like basement. We've done some traditional detrital zircons on some of these rocks, but we've also tried some novel techniques with University of Adelaide, Alan Collins and co, looking at rubidium strontium on some of these rocks that you wouldn't necessarily traditionally date and look at with detrital zircons. And we're getting ages that you can see through here. We're getting things that marry up pretty well about what we know with the regional geology. So if we're looking at a 530 plus or minus 30 MA age on some of these sedimentary rocks, then maybe we're looking at a bit of a mixture between a detrital signature, maybe some diagenetic overprint there, and maybe even some metamorphism on top to confuse the issue. But what we really can see is that the magmatism and the sedimentation is happening at the same time, and that's shown in the top right, where we can see exactly the same inherited zircon pattern resulting from the shrimp dating of the granites and the volcanics. That exactly mirrors what we see in the detrital zircon patterns, and that's shown in the rubidium strontium as well, that all these things are happening within that same window. So what does that look like? We're taking through a progression of rift development and then closing. That'll be somewhere along the lines of the cartoon graphic there. Magmatism starting around about 513 MA and down to about 505. Again, in that realm between the Normanville and Kanmantoo groups, we really got the basins coming quickly in after the extrusive volcanism, and then we've got closure happening, and then the granites popping in afterwards. And that really ties in quite nicely with what we see of the bigger architectural systems happening out to the east, and the subduction systems that we can see producing arc volcanics within the Staveley zone in Western Victoria. But that's not the end of the story. So you can probably just about make out a deep seismic section that GA very kindly acquired all the way from the edge of the Gawler Craton across the Adelaide Rift Complex, across the Murray Basin itself, and that gives us a really important fundamental picture about what the architecture of this crust looks like. What we need to do now is figure out what structures were active at what time. We can see in the plot in the middle, which was some of Wei Hong's work, which has just been published in economic geology, about when some of the porphyry systems were active in the region, and that really starts around about 490 MA down to about 460 MA. So what we need to do is marry up what structures are active, what are the right timepieces that show these things are happening at the key times. So that's exactly what I've said there. We know we've got big structures going on. We know we've got big alteration systems, and we know from some of Marnie's work that she's just presented that we're seeing the right type of the right age that we expect to see, which is, we see 505-ish coming out of the Argon, and we see a younger overprint happening around 490. So that's exactly what we'd hope to see, and it also shows that the 490 picture is not just confined to a belt of granites. It's the same ages that we see from Kanmantoo that Peter Rowley's talked about, and it's happening well under the Murray Basin. So it expands that footprint when you just need to work out what are the key structures for activating some of these areas. There we go. We're not just tackling regional geology, we're delving a little bit deeper into some of the analytical work with our MinEx partners. So we've got a project going with Adrian Brodadowo looking at pyrite chemistry, comparing some of the pyrite we've seen in drill samples to, I guess, known standards of sedimentary pyrite, porphyry-style sulfides, as well as those with VMS type affinities. So that project is ongoing. I'm looking forward to seeing some of those results come up. And that's part of a bigger study that is going on within collaboration with GA across the whole of the DCD area. So there's a big pool of data that will be coming out. We've also collected some mineral chemistry on some of the slightly transported cover sections. And what you can see in the bottom right graph is zircon age along the bottom and europium number up the side. So that gives a bit of a picture around what the fractionation trends are showing from some of these zircon grains. And really what you want to be seeing if you're looking for porphyry type systems is a big shoot up on those graphs. Now, intriguingly, we can see, well, obviously we're sourcing some of this zircon from external to the Delamerian. That's coming in from further east, most likely, from Eastern Australia. What we can see is interesting spikes around 420. So we've shown that we've seen some 420 ages and talked about that a little bit. Also from the same hole that Roche talked about, same hole that Marnie showed 420 ages as well. So there we go. That's what that rock looks like. So we can now see that we've got a 420 granitic type intrusive. It's got the right sort of chemistry. The zircons are showing that it's quite fertile for porphyry type systems. And really that opens up a bit of an extra play really in the porphyry world. It's an age that's not common in South Australia, and it's quite new and interesting. So going back to the initial goal for MinAx and the NDI, the idea was to open up new frontiers, go through and test a new wave of drilling and sensing technologies, bringing in some new predictive power, and really developing new knowledge, ideas and toolkits about how you might want to explore in a virgin terrain. So the Murray Basin's a great example of that, where people weren't traditionally active for a long time, Hillgrove aside, in South Australia. So really I think we can tick a lot of these things off. We've gone into a new and covered terrain for us. We've applied a lot of these new and developing technologies. We've predicted some geology, we've gone out and tested some geology, and we're in the process now of wrapping these things up together and showing how you can use to apply some of these developing techniques, such as looking at the base of cover zircons and things like that, and how that can actually vector and point out and highlight some areas of high potential. So going back through this timeline, earlier on this year we released the Quandong Vale area through the exploration release areas process administered through the Department for Energy and Mining. And what we wanted to do is highlight our learnings, I guess, from the project. So I've got my inverted triangle there, showing what data sorts we collected, how we value added on top of that data, and the insights that we've looked to build throughout this project journey. So that's showing evidence for porphyry and VMS type systems, the potential for uranium and heavy mineral sands, being the sorts of appropriate models to tackle this terrain. And we were very pleased to show that ground was taken up on the back of this work. We've got a number of companies that applied for ground, and a number of companies were successful in following up on some of the geology that we generated and released as part of this project. So that's really a template for what we wanted to do. It aligns really well with what Roche talked about in the Darling, Kernamona, Delamerian, whichever D is D. And we're really pleased to be able to both work in our patch of the Delamerian, but also work across the states, particularly with things like the deep seismic line. That's a great cross-border venture and working nicely with New South Wales, Victoria, and talking to Tassie. So, where next? We committed $5 million to the NDI. We've spent half that. So we've now worked through what this project can look like, how we can look to tackle a geological survey going into an area that's not seen exploration, that's not got active companies in an area. So we've developed a bit of a template, and where are we going to apply it? next? Excuse the pun. So for us, I'm very pleased to be able to announce that our next drilling area is false click of the button. We're going to be working in the Northern Gawler Craton. So how did we come to this area? We looked for areas that were amenable to drilling with a CT rig, so somewhere less than 500 metres of cover. We looked for areas that had vacant ground. We looked for areas that we could look to lock the ground up, do a coherent work program, identify and use a similar template that we apply for the Delamerian, and look to attract exploration in. So the Northern Gawler Craton is in an area that stands out pretty well. We'd look to have a copper gold focus, as well as investigate the potential for nickel up there. It's an area that's had exploration building and growing, and companies have been going further north over the last 5 or 6 years, which is an exciting place to be. We can piggyback on the northern limits of where companies are currently exploring, really come in hard and fast with hopefully a 2025 drill hole program, really tackle and map that basement geology with the CT rig, and then really try and understand what the basement rocks are up there. There's some ideas been published which are fantastic. There's been some work done out of Adelaide Uni showing that there's copper systems active potentially younger than the 1580, 1590 IOCG type story, down to 1500 or so. And we can also try and link in whether the rocks up there are typical Gawler Craton affinity, so you'd be looking for similar IOCGs as Stewart Shelf, maybe Mount Woods, or whether we'd be looking at things more similar to the Beacon-Denison domain, which has seen a real big exploration flurry in the past 5 or 6 years because of the strengthened links with Northern Australia. So we want to take that approach, apply that a little bit further west in the part of the Northern Gawler that really it's not known whether we're proper Gawler Craton rocks, whether we're maybe more like Northern Australia rocks. So what we want to do is come in hard and fast and find out. So I showed a map for the continent, and we've tried to attract people into the South Australian part of the Delamerian. We want to do that to the Northern Gawler next. Thank you very much.